Hi. Okay, great. Hello, everyone. In this edition, myself and Maze are going to be playing around with large language models, and we're going to experiment with different things using Python. We all know that AI is now taking over the world, and here we're just going to have a little play and see what the latest developments are and what we can come up with. So, Maze, could you introduce us to what you'd like to be building today?
Hi everyone, I'm Mace, and so today we are building a serverless application, and we will know in a minute all about that. But the general idea or the application we are building is a service. So it's a service running on GoogleCloud, and this service is behind the scene using a Python and LangChain to make a simple chatbot. So this chatbot will have this endpoint, our service, on the route chat. We can send a message and let's test it. And we are expecting Palm to reply back with an answer.
When it comes, there you go.
Here we go. So it's introducing itself. Good. We don't have to introduce it. So it's Palm, Google's large language model, which Bard is built on. I think Bard today was made available for the EU people. So congratulations. And it also got the Arabic language, and so I'm happy today. Finally, I can talk to it with Arabic.
See that as well.
All right. Yeah. So let's get started. This is all going to be practical. We're going to make a lot of mistakes, so please bear with us. I'm first going to introduce you to the tools that we are going to use to build this this little service. The first one is LangChain. For those who don't know about it, LangChain is a framework for developing applications powered by language models. Now we know large language models like ChatGPT and Palm are getting very popular because of how smart they are and how nice they are when they talk. So LangChain is trying to make use of these large language models in actual applications. So LangChain is data aware. It allows you to connect your own data sources, whether it's on Firestore, SQL, all different kind of databases really. And it has, it's agentic. You can act with the environment, not just question and answer, but with your actual app environment. So that's very nice. LangChain is very big, so there are many use cases that you can do with LangChain. And we're going to explore just a very tiny little bit of it today. The second service we're using is Cloud Run. So Cloud Run is containerized serverless, like we can deploy containerized serverless applications on it. And for those of you who are familiar with Firebase functions V2 right now are using Cloud Run. So it's like the more custom part, the more custom service underneath Cloud Functions or Firebase functions, V2. So some key features, you can write your app, unlike Firebase functions where you are restricted to the languages that Firebase functions SDK support, like Node.js and Python. In Cloud Run, you can build your app really in any language. You want to build it in Dart, you can build it in Dart and deploy it, no problem. And you can use the containers and all of that on Docker, of course. There are many use cases and many amazing custom things you can do with Cloud Run. And we will explore it today more. And the last thing is Fast API. It's a nice framework for Python for building APIs. I really like it. It's easy to use. Let's get started. Okay. The first thing we're going to start with is, let's create a folder. App is where our app is going to live. And then let's create a Docker file, since this is Cloud Run depends on containers. So we need a Docker file to define our containers and all of our dependencies and expose our app on a certain port and host. We're going to see all of that in a minute. Final thing we need is requirements.txt. So that's for people who are not familiar with Python. That's like package.json and Node.js. So for the requirements, let's start with the requirements. I'm going to copy paste. These are the requirements we're going to use. We're going to use Fast API, obviously. Pedantic, which is like you can build data classes and models using Pedantic. It's very nice for Python. And Firebase admin for Firebase stuff. LangChain, and finally GoogleCloud AI platform, which LangChain depends on to use PAL. Save, and let's move on to the Docker file. So in the Docker file, the steps are very simple. For those of you who are not familiar with Docker, Docker is now I'm not really an expert in Docker, but for the short period I used Docker in, it's really nice in that you can contain your whole app in one process, and this process is isolated from your host machine. You can, like in Python, for example, when you install the dependencies, it's public in all your system. So you need some kind of a container or something to scope your dependencies to your project so it doesn't conflict with another project. Docker works with the same idea. So you can have 1,000 containers running on the same server. All of them are not aware of each other's, but they can talk to each other's, of course, and they can talk to the host machine. So a Docker file is basically a file that tells the Cloud Run the instructions it needs to run your server app. So the first thing we will start with is we will define the image that we want to start from. So we will start from a Python Slim image. That is an image on the Docker Hub. So you can find it on the Docker Hub. And it's just an image that contains everything you need to run a Python application. The minimum you need to run a Python application because it's a Slim version. Next, so once we get the image running, we will change our work dir inside the container. So it's not app, it's code. So this is gonna change the, let's say, your working directory inside the container. So now your container is different from your device. It's not your device. It's not this workspace. It's somewhere else where you can move and change your working directory. So we will go inside a directory named code, and then we will copy from our source code, we will copy the requirement.txt into code. So let's use the copy command, requirements.txt into code / requirements.txt. Once we copy it, we can run pip install. So let's also cache it. Cache. No cache. Spelling mistakes. Let's also make sure to upgrade pip and what they are at the end. So this is the command we're gonna run to install our requirements inside the container, right? We also missed, yeah.
Do we need code requirements in the pip install? Is that a, since our code directory, if we run installs, it needs to be in code /
Yes, good note, good note. Thank you there. Yeah, since we are running, like we're gonna run this inside the container, so we need to follow the correct path. We also forgot to set an environment variable, Python stuff. Right. Now that we have our requirements in the container, we will copy our code. So copy app, the code that's going to live inside here. We still don't have any code yet, but it's going to be inside here. So we'll copy it from app into code app inside the container. Why are we using code as a work directory, there's no special reason. You can really name it anything. You can even make it a root directory. It's fine. Just to differentiate it from my my root code here. Now, finally, we have the app, we have the requirements, everything is ready in the image. We will run the application. So we will serve the application. And this will happen by calling CMD. Thank you, Copilot. To serve it on this host and on port, I think it's 8080, yes. So 8080.0.0.0, it's required by the Cloud Run contract. So Cloud Run, unless other specified, the default host is going to look for your app on this host and on this port. And we will use UVcorn to run it. It's not like a Flask application where you can use, I think it's called Unicorn, not Unicorn, G-Unicorn, yes, G-Unicorn to run in Flask applications. But we are using Fast API, and UVcorn is used with Fast API applications. And this is our module. We'll create it in a minute. Already, this is our Docker file. We can close it and move forward. Now we have the requirements and dependencies ready and the image ready to set up. We'll go inside app and start writing our code. So main.py is the first file. And in here, as you've seen, we have one route, which is chat. That is a post route. So let's start by initializing a fast API, import fast API, and then we initialize the app. Then we will use the app to create a post route, which is gonna be chat, right? And then we define the function that's not gonna be async. And let's just return something to test. There is another endpoint that I didn't show you, which is gonna be clear session. So clear session is gonna remove the current conversation from Firestore, because all of the user conversations is gonna be saved to their own document, to their own sub-collection on Firestore, so that they can, if they close the app, they can return to it again. Clear session is gonna delete all the session, so they can start over. So we're gonna make another post. This time we'll call it create session. Find it, return hello world. Let's start with this. Now next, since we are using Firebase, and as we know, if we want to do anything with Firebase in a server-side environment, you first need to initialize Firebase admin. So let's import Firebase admin. Firebase admin. And inside Fast API, we're going to add a dependency. Dependencies. And this dependency is going to be, it's not going to be Firebase admin dot initialize app, like this. All right. So the app is not going to start before Firebase. The Firebase app is going to be initialized, and then the Fast API app is going to be started. Now, the next step is to make the body. So our service accepts a body that is JSON and has a key message. So let's see how we can do that. I will create a new file. Who do you want to message? That's silly.
Always helping.
Always answers when you don't want it to answer. So let's make a new model in a new file called chat message. So we're gonna call it chat message, and this is gonna use pedantic. Let's import pedantic, or actually it's from pedantic import base model, and then we say chat message. We're just creating a model that holds. I'm gonna use the user. that holds the body we want to be sent in the request. Let's save that and use it in the chat function, the chat route, as an argument. It's not going to be a string, it's going to be a chat message. Support that. All good. So this way, Fast API is going to parse this as a body. It's very nice. Let's test out things. Or actually, before that, we need to start a debugging session. So to debug a Fast API app, we can do it easily from. We can do it from the terminal, but let's create. Let me actually copy the configuration I have for VS Code. So that will give me a launch.json file. We'll launch the app basically using UVcorn in a debug mode. So start debugging. Oh, I think I'm already serving another instance. So try again. Here we go.
Nice.
So we have an error that I've never seen. Here we go. So attributed function object has no attribute dependency. Dependencies, yeah, where's that? Ah, I see. This is it. So dependencies is actually a list of depends. So we need to use this this type from Fast API. Let's import that. Runs. Here we go. All good. So our app is serving. Let me just get rid of this. Yeah, it's serving UVcorn starting on this. So let's copy that. Put it here. We'll go to the route chat. Let's just see. Here we go. Hello world. As we have sent, returning a message of hello world. So from here, we can start. The first step, before we start with the chat itself, the first step is to implement authentication. You don't want anyone to just call your service, call the service and just run it without authentication. So for authentication, we're going to use Firebase authentication. So let's go to our project. I actually forgot to mention. I forgot to mention that we need to have a Firebase project in order to follow up with this stream. They're not following up with the stream. And inside the project, you need to have authentication on. So, and create a user, any user, just add user, create an email and a password. This is needed for the next step. And another step is to have a Firestore database. So let's create one together. I'll start it in test mode since we are just testing things. Why do we need Firestore? Because we don't want the messages to be lost in memory. We want to persist it outside our service memory. So we will do that inside Firestore, and we will see in a minute. So let's start with authentication. To do authentication with Firebase on Cloud Run, or on actually Fast API. That's basically Fast API. Let's create a new file. Not folder.
To mention as well, for when you're setting up your Firebase project, when we're dealing with cloud functions, you'll probably need to upgrade to the Blaze plan. So we're currently running Blaze and we've upgraded. When you starting our project, it will be in the Spark plan. So we did that step in the project as well.
So it's not it's not visible, but this is it.
Somewhere there.
Yeah, somewhere there. So you need to be on the Blaze plan because otherwise, I think you cannot deploy a Cloud Run container. So where were we? Yes, in auth. So in order to do authentication, we will create a function. This is the first step. Verify user, and verify user, just to start it. Verify user will take credentials. Okay. And these are going to be HTTP authorization credentials. This is coming from Fast API. So we'll import it from Fast API. And that will depend, so depends on, not Firebase auth. Also import that. That will depend on, or the type of authorization is going to be HTTP header. That's also coming from Fast API. And we want to turn off auto errors to control it. Yep. So this is by default gonna come from Fast API, from the framework, when you depend on this function. So let's see how we can use it. It's gonna be user, which depends on verify user. Yep, let's import that. So we will have a user. Where is this user coming from? It's coming from when we decode our bearer token that is coming from the user. So the bearer token, how can we verify it? We can verify it by using the Firebase admin. So let's try decoded or token return. Okay, auth, that's very well done. So the Firebase admin SDK, the authentication model, provide us with this function, which verifies the signature and data for the provided JWT. That's coming from the headers and will be passed down into this function. We will verify it. So create.credentials. These are usually the ID token. Then if anything goes wrong, we're gonna raise an HTTP exception. Yep. Or no. This is coming from Fast API. Is it?
HTTP exception. That should be fine.
Yeah.
Yeah.
From API. There you go.
While we're here, Maze, for the verified ID token, do we need to check for revoked, or is that just an optional thing that we could?
Oh yes, that's a very good point. So we will set this flag check revoke to true. This is because an ID token coming from Firebase authentication will expire every hour. So usually when you are using the Firebase auth SDKs from a client side, like in a Flutter app or on the web client side of things, you don't implement a logic to every hour refresh the ID token of the user. This is happening for you by default from the SDK. So the SDK itself is going to do the refresh without you bothering with that. We want this function to check if this ID token was revoked. And when does that happen? If the token expired, if the token was, like, if the user was, we manually revoked the token from the admin SDK. And I think there are a couple of other use cases, but generally we want this to be true for this use case. I want to check if this is revoked or not. And there's a nice thing in Fast API, which is status. So we don't remember. Let me import it first. We don't remember all the status codes. I want unauthorized. So here we go. Unauthorized. All right, so if everything goes okay, we will return the verified ID token, which is going to be a dictionary. We will see how it looks like in a minute. Otherwise, we will raise an unauthorized exception. And let's also put this here. We want both endpoints to be secure. And that's it for authentication. Let's test it out. So here, we'll turn off, I'll turn off authentication. So we don't have an authorization header anymore. Invalid credentials. So that's working perfectly. Let's move to the next step, which is implementing the chat. So the chat functionality using LangChain. For that, let's create a new file. Let's call it chat.py. And inside chat.py, and we will need another file. So the chat functionality has two sides. The chat calling the LLM using the API, Palm API. We will not use the Palm API directly. We'll use it through LangChain. And the other part is persisting the messages in Firestore. So the first part is going to be in chat.py, and the second part is going to be in history. History.py. Before we start on that, I want to show you something here. So if we go to the modules in LangChain, let's go to, I think it's in data connection. Nope, in chains, probably. Yeah, here. So foundational LLMs, we can see here how we can call an LLM chain, which basically takes a prompt from a template. So you can modify this template to give your, like, for example, if you want to tell your LLM to act as a cat, so you will give it, answer all your questions with meow at the end, and this is going to be your prompt template. And then you execute, looks like this, LLM chain.protect. You give it the whatever prompt you have, and it's going to give you back the answer. What we will use is, let me try to find it. I think it's conversational somewhere. I always lose my way in the documentation.
So much to this bit, isn't there?
I know, right?
A document load is so long.
Where was it? Where was it? Is it agents? What are we using? Conversation chain. What is it?
Look for conversation.
Let me search. Conversation. Here we go.
Oh, easier.
Let me just make sure. Nope, it's not this one. This is an agent we're using chain. Come on, where are you?
Is it customizing conversational memory? Looking for.
Customizing, you mean in memory?
So we have modules, memory, how to. And then how to customize conversational memory. Is it this one?
Here we go.
Ah.
Found it. Thank you. All right, so I think I took it from here. So in a conversation, like there are many types of chains in LangChain. You can have a chain that only answers questions. You can have a chain that takes in data sources like Firestore data or text file, text data or PDF data, whatever. And this chain is what we are interested in, which is because we are building a chat application. So we will initialize a conversation by giving it an LLM and a conversation memory. This conversation memory is gonna start by loading the messages from Firestore, which we have persisted before this step, and load it into the model. So the model have in the context have or know the previous, let's say 10 or 20 messages that it had with the user. So if you ask it about something you've said 5 messages ago, it will like know that or answer you as it has memory. All right, so this is the first bit I wanted to show, and the second bit is memory. Not memory, actually, it's history, because there is a difference between memory and history in LangChain. I'm not going to go into that. But yes, we want these integrations. So you can save your chat history, your user's chat history in any of these integrations. DynamoDB, MongoDB, Motorhead, I think that's it. Motorhead, Postgres, Redis, any of these. We can't see Firestore, can we? We want to use Firestore, but we can't find an integration for Firestore. In fact, I think it's not documented yet, but there is an implementation for Firestore in LangChain. I think it was in LangChain memory dot.
Let's see.
Yeah, it's in memory. So memory, import, Firestore. Where is it?
Is that the conversation buffer memory? Is it Oh. Are we looking for the Firestore chat message history? That's in app.history, which we were using.
Yeah, but I forgot in which module it was, but there was a Firestore history, but I didn't like the data structure, so we will re-implement it ourselves. We're not going to use the one provided by LangChain. Just wanted to point out this, and then what? Let's start making our chat object. So every request to our service is going to have a chat session or a chat object. So let's start by creating that chat session class. Nope, like this. So the class chat session is going to have, or the first thing it's going to have is an LLM. So we want to know which LLM we can use. We will make this general. In this stream, we're going to use Palm, but you can really use any like from LangChain, because LangChain has a lot of LLMs inside of it. Oh. So let me show you. Chain. It was inside chains. LLM. Nope. Model IO. Yep, here it is. Language models, LLMs, integrations, and here you go. All of these LLMs are available inside LangChain. You can find OpenAI. You can find, I think, Cloud. There's another model called the Cloud. Cohere. You can find it. Whatever. I only know Palm and ChatGPT anyway. So yeah. So these are like the most popular ones. And the next thing we will initialize is a Firestore client. So because this is gonna use Firestore as a session, so we want a Firestore client to be in there in the session. So it's let's import the type cloud.firestore import client. Okay, and the next thing we want to have in our object is a history. So this is gonna be base chat message history. And this is also coming from LangChain. So this is important from LangChain.schema. Finally, the conversation itself, because we said we'll use a conversation chain. So we're gonna keep that in in the object memory. Conversation chain. Let's also import that from LangChain. Perfect. Put these together. All right. These are the 4 things we need to initialize. Let's start by making the constructor. ID where equals there equals. Okay. I forgot to initialize one. I mean specify one parameter, which is the user ID. Because if you want a chat session, and since we are persisting the messages in Firestore, we're using the user ID. All right, so the user ID is required when we initialize this object, right? And we want to set the LLM. This is like a one thing setup. And now we choose our LLM. So we will go to from LangChain.LLMs import vertex. So the question is, why is it not called Palm there?
That's a really good question, isn't it? Vertex is a wrapper around Palm.
Yes, the Vertex AI is like a big, the AI platform on GoogleCloud. Palm on itself is an API that allows you to use Google's large language models. And you can access it through Vertex AI. Since it's an AI thing, so it's available on GoogleCloud, and we can access it through Vertex AI or through the Palm API directly. Both options are available. So we will, or the integration that LangChain has is using Vertex AI. And to use Vertex AI, like you would normally, to use any API, you would normally need an API key. But we're not providing any API keys in our application. The reason is we are deploying this app to Cloud Run, to Google Cloud. And anything you deploy to Google Cloud by default will get the application default credentials, or ADC. And this is like your app, which is deployed to GCP, has access to all the APIs that are enabled in your project without providing any API keys, because they are running on the same platform. So we will be able to use Vertex AI directly without providing any credentials. So let's initialize Vertex AI. And that's it for initialization. We're not going to initialize these 3. We will do, but I'm going to put them in another start session. I'm going to put them in another function just to make things clean. What is this? Div. Okay. The start session is going to initialize the Firestore client, history, and conversation. So let's start. The first step is history, because we need to initialize the history before we initialize the conversation, because the conversation is going to initialize the LLM and will have a prompt template inside of it. This prompt template is where the conversation history is going to live. So after we extract the conversation history from Firestore, we will have like a list of messages between a human and an AI. These messages, we can put them in a long string, and this string can be provided to the LLM as, here are the past messages you had with the user. Please answer the questions accordingly. So if you have this in your prompt context, then the LLM is going to have some kind of memory. It's not a very fancy memory, but it works. So the LLM is going to say, I know what I was talking about with this user. Let me continue. So let's start with the history. And this is wrong, of course. Thanks, Copilot. This is going to be the Firestore chat history that we will work on shortly. Let's call it Firestore chat message history. This is not initialized yet. Just to give you an idea, this is going to take a user ID, because we need the user ID in order to track the collection. It's gonna take the user ID from the session, and we need a collection name that is where the messages are going to live. Let's call it chat history for now. And finally, a session ID. For simplicity, we will use the same user ID. But we can go like one step further, and for each user, we can have multiple sessions. But for now, let's just keep it as simple as possible. Now, finally, we will have the conversation. So that conversation equals conversation chain. We have it from LangChain. This is it from LangChain. The conversation chain will take a memory, but this is not a history. Like this is not the same type as this. So this has to be a conversation buffer memory. So the memory is going to be initialized with a conversation buffer memory. Let's import this. I think it's from LangChain memory. Yep. But this is not the same as this. How are you going to pass this to this? So the answer is there is, I think, a history here. Memory key. There is something called memory key and a chat memory. So the chat memory is going to take the history, right? The chat memory is going to take a base chat message history, which is this class is going to depend on this, right? So we will do it in a minute. Let's also say return messages true, so it can be returned template, and our LLM, which we initialized already. All right, finally, of course, let's call this start session. Start session. Let's write this Python syntax. And finally, in our history, we will initialize a Firestore message history, but of course, we said this has to extend base message history. History. From LangChain. Let's wish I remember the import correctly. So LangChain.memory, I think. Import
Yes.
base. Okay, that's wrong. Is it? Yeah, it's wrong.
Base message tree. Is it schema?
Chat memory? Ah.
I think you can get LangChain schema has base chat message history. It's a LangChain.schema.
Yep. You are right. Cool. Thank you, Darren.
With Copilot. It helps at the end, doesn't it, Copilot?
Copilot developers. No developers anymore.
The future.
Yeah. So I said that this is already implemented in LangChain, and I need to find it because I need to copy it. So let's let me go to LangChain. So LangChain Firestore memory history. Let's see if this is gonna work. I think I found it in the repo.
What's this bit we're looking for?
We are looking for Firestore chat history. I want to know in which module it is so I can import it. It's not in the documentation. So I think it's in memory. Chat message histories. Here it is.
Oh, there's
Firestore. There you go. So let's just take a look at the implementation. They are extending base chat message history, taking all of this information, and then prepare Firestore I'm gonna copy this one because it's important. Well, I can probably try to extend this one, but it's like, actually, let's try to do that. Let's extend this one. Import LangChain .memory .chat memory. Chat messages. All right. Let's use this alias just to differentiate it. Yep. So let's extend that. And the two methods I want to change are ones that are dealing with the data structure. So in the original, let's take a look at the original history. So it repairs Firestore. Well, okay, that's fine. Then load messages. We can note here that if we go to the self.document, it's storing all the messages. Yes, here. It's storing all the messages in one single document. So single document that has a field called messages, and this field has a long list of messages. And every time we want to add a new message, we append to this. Like we set the same document. Now, I wouldn't imagine a chat, like if I want to do my chat application on Firestore, I would want to have a separate document for each single message. So I'm gonna extend this class just to change this bit only. So let's see which one are we going to override. Load messages. Okay, load messages. We're not gonna call super, of course. This one, we will say, I'm gonna copy it, right? So because we have no time. So this is my implementation.
It's still your implementation. Sure, that's fine.
Yeah. So instead of a document, I'm gonna use a collection. So we will have, for each user, we'll have a single collection, and this collection will have documents. These documents will have, like, each document will represent a message, a chat message. So the other one, we want to say diff add messages. Yep. So we will also implement this one, add messages. And because now we don't have a single document, we have a collection. So we'll change this as well.
I think this is the same code. Is this the same code as above?
Yeah.
Oh, okay.
So if we go to the original chat message history, what we are doing is overriding this and this, basically. And then I think this one as well, because this one is deleting a single document, but now we have a collection of documents. And in order to clean or delete a collection in Firestore, you need to delete all the documents in it. Like there is no command which says collection.delete. So that's another one to implement. Of course, this is wrong. For in git this is wrong. Doc to delete. So we're deleting every day. To be honest, I'm not sure of the syntax, but we will see in a minute when we test. And all of them, we're making sure the collection is initialized. And this is wrong, by the way.
Yeah, Fimez, this should be adding a document through
Yes.
self.messages.
So let's move this
Yes.
and do this. I'm going to copy paste. All right, import datetime. So what we are doing here is we have a list of messages, local messages saved in the object. We're appending the message. And then self.firestore client. So we need a Firestore client in this. Dot collection. This is the collection. It's going to be collection name, which is chat history, what we chose. And slash the user ID. So this is the user document inside the chat history collection. And inside of that, we're going to start a sub collection with the session ID. So each user can have multiple sessions through a sub collection. Then we add a new document to the sub collection. We will have the data, which is the message. The type, since we are storing every message in a separate document, we need to know who sent the message. Is it the human or the AI? And when was it sent? So when we query it, we can order by date. And when we load the messages, of course, the history, we're going to order by timestamp in descending. We want the most recent messages only to be loaded. All right, and that's it for our Firestore chat history. Let's save and import and save. Right. There's one other. We need also to reload, override, def, prepare Firestore as well. So that's because we no longer have a single document, we have a collection. So let's override this. We import Firebase admin, and then we get the app with the logo. This one. Whoops. None of them is correct. From Google.
Is this for the logger?
No, this is just the prepare Firestore.
Yeah.
Because in the original one, if just to see why I'm overriding this, the original one, if we scroll down a little bit, we will see it's setting a property called self.document. But here we are not using a document, we're using a collection. So I'm setting a local property called call, which is better to be renamed into collection. It's more clear. And we are setting the Firestore client, of course. So that's why we need, I think we don't need this part since we are sure we will have it initialized. Also imported, so we don't need all of this. Here we go. Now I think we are good. So now we have our chat and we have our history. Let's actually implement the endpoint. So the first step is let's erase this and say try chat session equals chat session. And since now we have our user, so we can say UID equals user UID. The UID exists inside the decoded token. And then we will say chat session dot add message. We have it. Let's just make sure. Oh, we don't. I'm sorry. We didn't continue implementing this. let's do. Yeah, we need a add message. The message is gonna be a string, and we will call our conversation. We don't need this long. So we call the self.conversation that we initialized in the constructor, and we add a new message. Is it add message or run? I think it's called run. LangChain. So it's run, yes. Executing a chain when there is a single string output. All right, and that's it. So now we have it. Thank you. Let's raise an exception if anything goes wrong. Accept exception. Raise HTTP exception from Fast API. Nope. Is this correct? Yeah. I can find it here just to make sure. Nice. There we go. All right. Raise an HTTP exception. Perfect. Finally, this one will initialize. We need a clear, we didn't implement that. Let's implement it. Clear partition. We'll call self.history.clear, which we implemented inside here, this one. All right, that's it. Now let's restart that and test. Now, the first step is if I call this, I'm gonna get another invalid credentials, of course, unauthorized. So I need an authorization token. Now, for testing, this token can be get from the client SDK in Firebase if the user logged in with an email and password. But because we don't have a UI in this demo, so we are going to do a workaround, and that's gonna be, we go to authentication in the Firebase, in our Firebase project, we add a new user. In our case, I have a user, which is this@gmail.com. And I know the password for this one, it's just for testing. And then you go to project settings, and you're gonna find, I'm not gonna go there because there's an API key there, but you're gonna find with API key. You need to copy that one, okay? I'm gonna copy it in another screen. And if we go here, and I'm just gonna, here. So I'm gonna call this endpoint, the identity toolkit with a verified password, and I will give it my API key. It will return to me like a decoded token, the ID token. And this ID token is what I need to authorize my request to the API. So I'm gonna paste my API key in another screen. You wanna run it? I'll get an ID token. I have an ID token now. And then we go to authorization. So I'm using Postman here. You can use it, do it using CURL if you want. So in authorization or in headers, so it's headers here, authorization. We can add the token. We go here, authorization, and it's a bearer token. And this completes our setup for a test authentication. In real life, you will get the ID token from your client-side app. Then we will have the body. We need a message in the body. And I think if I run this, it's gonna work. No? Okay. Yeah. Internal server error. Yeah, so it's not gonna work, of course. All right, so the default Firebase app already exists. Not sure what's going on, but let's restart this. Do we have initialize app anywhere else? Oh, yes. Oh no. We are overriding this, aren't we? This is the original one. Prepare Firestore. Yes, we are overriding it, so it shouldn't run.
Does that get compiled and run, maybe?
Let me put a breakpoint and see. Oh, yes. No. The initialize app is...
Can we comment the line out for now, maybe?
Yeah. I'll put a breakpoint. Let's see. All right. Okay. Seems working. Maybe because we need to restart. All right. One validation error. In content store type expected, blah, blah, blah. So we have a problem in our parsing here, I think. Add message. Let's go to... Nope.
I was typing, did that breakpoint for you, or this is...
Message content store type expected type error. Let's comment out the history for now.
On the chat session, I noticed that we overrided and put none as a default for the parameters. Is that needed in the constructor or function parameters?
Which one?
So I think we've got, let's see, on the chat session class, is it UID? Oh, maybe it's further up. See, the history and conversation can default to none. And so you go to the top of the file for the class.
This one, you mean?
So lines, oh, sorry, go back to the chat file. The history and conversation, we've set those to none previously on lines 18, is it? Up a bit? 15 and 16.
I don't think this is related, though.
Can we see the error again?
Yep. So we are not logging here. Might be more useful. Go to main chat session here. Okay, this is more useful. Or not useful. What is this? All right. It's from not Fast API. Where is logger? And then it's logging. One validation error for human message. It's not from the history, by the way, because I commented that out. Let's debug from here. I see. We are not sending a string. We're sending the whole object.
Oh, that's interesting. Chat.
Yeah.
Did we
This is a
define
live
that
stream
within the
error.
model? Does this come from the model that we defined earlier?
Yep. So I had to say message.message, the content inside the message. Amazing. We got it. And of course, we have null because we didn't send back the response. Say return message. And of course, we need to return from here as well. Like this. Let's run again. Here we go. Finally, 1 hour of fighting. All right. We replicated the app finally. So, and let's actually check our Firebase console, see if we have any documents. We don't. Yeah, okay. My bad. I commented out the memory. Yes. Phew. Let's try that again. And by the way, the request is kind of slow, and we're going to solve that in a minute. There's something about caching.
Chat history.
There you go. We have a chat history. This is the user ID, and this is a session ID. And this is the first message, my message, who are you? And I am a human. And this is the AI. I am powered by Pound 2. All right. Mission accomplished. I want to try clear session, but I'm a little bit afraid. But let's go for it.
May as well, it's a live stream. You can see.
I think I did a mistake by putting initialize app here. Let me take it out. Chat session object has no attribute clear.
Is it clear session?
It's a clear session, yes.
Self history clear.
Okay, I suspected it's not going to be correct. Self.collection.get document.reference. I think Copilot was correct. Let's try again.
Oh yeah, originally we had self.documents.delete. Correct.
We're not starting. Yeah, here we go.
How's it working?
Because when we call get on a collection, we're gonna get a list of document snapshots. So that's different from document reference. Let's just make sure this was deleted. Yep.
Yeah, cool.
All good. The whole collection was deleted. So our app is working perfectly. We did a debugging session. And now the last step is, and by the way, this is something I had to show at the beginning. I'm just wondering, how is the app working and I don't have a VM?
Magically.
Okay. It's using my Conda environment. Oh my God. Conda deactivate. Thank you. So if I try to run the app, it's not gonna work now. So if I say, because for local debugging, I usually either use Conda if you are familiar with Conda and Python Anaconda, or VM, which is like the default choice for managing Python projects dependencies. So what we are going to do to initialize a virtual environment is, and this is only for local debugging, we don't need that for Cloud Run, for deploying on Cloud Run. So we first say Python 3 initialize a virtual environment, and we can see a new folder was created here. And then we're gonna source our terminal to read the Python from here, not from my host machine. So now we have VM. And then we're gonna install the requirements. Hi, Jacob is a fan of poetry. There's also another tool called Poetry. I haven't tried it personally, but Jacob have tried it, and he says it's good. It's good for Node.js developers who are coming to Python and thinking it's, yeah.
We're going to be showing a lot of
Right.
techniques in this, I think.
Yes. So all is good now. This is, I think, now reading from my virtual environment. And for your information, everyone, we need to have GCloud CLI running because we are going to deploy to Cloud Run. And in GCloud, we need to set our, or actually it's not important. So I'm going to show you in one line how you are going to deploy your app, literally one line of code. So this is gonna be, let me find the command. All right, here. So it's GCloud run, the GCloud run from Cloud Run. So we're gonna go to the services provided by Cloud Run, deploy. Then we have to give a name for our service. So Darren, what do you wanna call it?
LLM, I don't know, LLM hosting or
LLM live stream.
Yeah,
let's go with that. And we're gonna specify the source. So what is our app? I'm gonna tell it it's in the root. You are right there. And we can, like this is optional, to provide a project ID. If you have the project set by default on GCloud, like the default project set, it's gonna read it by default. But just for safety, let's say, Cloud Run LangChain, I'm gonna provide my project ID, Cloud Run LangChain. And I'm gonna allow, this is very important, you can have your Cloud Run services very restricted such that no one outside your Google Cloud organization can call it. So only people with the correct IAM, what do you call it? Privileges, I think. That's the English word for that. Only people with the correct IAM permissions, yes, found it. Permissions can call this function. But for our service, we want everyone to call it. We want to call it from, like, let's say, a Flutter app, for example. So you need to allow an authenticated call. And that's it. Let's hit enter. I hope this works from first time. So now it's asking me registry artifact that Google APIs is not enabled. Would you like to enable it? Yes, please. Let's see. So deploying from source requires an artifact registry Docker. So this is going to create the container image for me on the artifact registry. I don't need to do it manually. So this is the nice thing about this command. A repository named Cloud Run Source Deploy in region Europe West 2 will be created. And this region is because I chose it. So I did set it as my default region. Do you want to continue? Yes, go please. Now it will start creating my container and function. So while we are waiting this to deploy, Darren, do we have any questions?
So I want to ask you is when this is deploying here, this is going to install all the dependencies in the container when it builds? This is the idea behind Docker has the instructions to install?
Yes, exactly. So this is in our Docker file instructions because we are copying the requirements.txt and then we are running pip install. So it's the same thing as we did in the virtual environment, but this time it's running in the container image. So yes, the container is going to handle that for us.
And so the idea is that once we deploy this, one thing I don't understand here is what endpoints do we have? We've exposed port 8080 and the container. Does that provide us an endpoint that we can now talk to the same we did locally?
Ah, yes. So you mean, are we going to be able to call this as we are doing from the local debugging session?
Yeah.
No, because this is only a local debugging session. This is going to be exposed so that Cloud Run is going to read it, like to talk to our server application on the inside the container image, and then there is like another endpoint exposed by Cloud Run, and that's what we are going to call. It's going to show just once the deployment is over here, we will see your function is ready. You can, like, this is the endpoint. We're going to get an endpoint that we can call. So the first time it's going to take a while, but yeah, I actually forgot to mention one point about caching. So we noticed that every time we are calling this, it takes around 7 seconds. And this is not nice. So we can make this better if we go to main. I'm going to do a little bit of caching here. So chat session, we don't need to reinitialize it every time for every user when they hit the endpoint, like whenever we are talking to the chatbot. So what we can do is we can take that out. So that's chat session as none. And let's declare it as global. So global chat session. And then if it's not set, we set it to the user ID. We cannot set it here because we don't have the user ID globally. But once we have the user ID, we can set it. Let's move this inside the try. And this is going to reduce the time of our request so much. So let's try that now. Chat send. So the first time we are initializing, of course, because we don't have the chat session. But once we cache it here, and global variables are cached between calls in Cloud Run. So this one is taking 7 seconds. What if, let's change the question. Darren, give me a question.
What is the temperature?
Right. What's the temperature like right now? It should ask me where, because I didn't give the location. Let's see how. Oh, okay, that's smart.
Oh, that's where we are.
Yeah. Is this correct, by the way? Someone can quickly check. All right, so
the comments can
we can see that this is taking now 2 seconds, 2 and almost a half seconds to execute, from 7 to 2. Sometimes it was taking for me last night when I was developing the sample, it was taking around 13 seconds every time. So from 13 seconds to 2 seconds, that's a huge improvement. Right, it's done. No errors from first time. This is very, very weird.
Good.
And we got our service URL. So it's saying service LLM live stream, the name I gave it, with this revision 1. Every time you deploy to the same service, it's gonna this number is gonna increase, and you're gonna like this just a random alphanumeric has been deployed, and it's serving 100% of traffic. So this is the service URL. If we take this and put it instead of our local host and send, so the first time it should take around 13 seconds because I didn't deploy this new change. So we're going to deploy it shortly. All right, cool. This took 7 seconds, even it's actually on the cloud. It's the same as in my local machine. Amazing, it's really quick. Let's send that again. It's going to be the same 7 seconds. So let's deploy our little caching trick.
So, Maze, while that is deploying, the advantage behind using Cloud Run and say rather than say just a cloud function, I guess there's going to be a number of advantages. Mainly that you could put a wrap around this, I guess, and call it from any language. There are in-memory advantages. Like, well, you could call it a container, say, instead of just using a typical cloud function.
Yeah. So the main big advantage for using Cloud Run, sometimes you don't really need Cloud Run. Cloud functions are more than enough. But sometimes you need Cloud Run. For example, if you are using Dart, let's say, there is no Firebase functions Dart SDK. So if you are building an application using a server application or a small service, you can deploy it to Cloud Run very, very easily. That's something you cannot do with Cloud Functions.
So then you can so you could write one container in Dart, and then I'm guessing we could deploy another container within this ecosystem that is going to be your Python LLM.
Yes, exactly. Let's actually take a look into the console. It's something we didn't do. So let's go to the Google Cloud console. This is our project. If we go here to Cloud Run, we can find our service here. This UI looks very much similar to Cloud Functions, the same UI. So you're going to have every function or every service you have listed here. Each one of them could use a different language. One of them could use Dart, the other is Python, the other is Node.js, the other is Swift. It doesn't matter, really, as long as you are following the contract that Cloud Run needs to run. You can view the logs here. And there's something we didn't mention. Cloud Run can be triggered not just only by HTTP calls, but also via event arc. Oh, I didn't want to. Event arc. Event arc events.
Yeah, just a separate enable service.
Yeah, so this is like cloud in Cloud Functions. You can have Firestore triggers, for example, on write, on create, on delete. You can do the same thing with Cloud Run. You can have one of your routes, or you can have a service triggered. Set up as an event arc trigger. It's very nice and flexible. Right, this is deployed. Let's try calling it again. So the first time is going to take around 6 seconds. The second time, it should be 2 seconds or less. It's 9 seconds. There you go. Even less than 2 seconds. It's amazing. Yep. And that's it.
Yeah, so I think this is really our first foray really into looking into Python and playing with LLM. And yeah, the idea is that we've decided we're going to try and show what's a hosted example, and we're going to look to try and expand on this further in a further series. So if anyone's got any ideas, or if there's anything that they'd like to see as inspiration, please add in the comments. And thank you, Maze. That was an amazing performance. I think we only had one bug, so well done.
Yeah, one bug only. So just wanted to mention that this full example is available on our repository, which is still private. Need to open that.
We could maybe link that in the description afterwards.
Yeah.
We'll add some resources from this as well. If anyone wants to do any reading on particularly LangChain, which, as we found earlier, there are so many sections to that. You could probably spend all day reading the categories alone. So we'll link that in the description also.
And that's it. Thank you everyone for coming in and for watching 1.5 hours of me playing around.
Hopefully more to come.
Yeah.
Okay.
See you all.
Thank you, everyone. Take care. Bye-bye.